Hello. We're doing this again, and if you read the title, you'll notice that it's PPU time, which I kind of dread as of now, but we'll solve it. I have drinks to accompany me. Non-alcoholic. I don't need alcohol to fuck up my day today. Also, some things I noticed is that I had my helpers.py still in my ROMs for like the very longest time, and that was the one I was editing, so I was theoretically working with inactive code. Anyway, I fixed that. I saved what I had in here, removed what I had in here, resaved this outside to here, and then removed that. Or I just moved it, I don't remember. Anyway, it was this file, and now it's in its proper place. But here's the thing, automated testing is no really longer viable. Here's what I have so far. Let's just run the test as of now and see what it does. Wait, quick check. I'm not resetting, good. So, we're breaking on the load A function. At which point you're like, but you tackled that days ago, and you're very correct, whoever you are. The thing is that we're accurate to line 863, and the LDA function is verified much earlier. So there's nothing wrong with the LDA function, I think. I've dabbed on it quite a lot, and it might be, well, I checked into if it was like a problem with the absolute reading, but it doesn't make sense because it's trying to load from the address after this. We can actually check what that address is. Why do I do that? Brain freeze. Come on. Bus read, damn it. There we go. So we shall bus read on CE22. No, CE1E. And that is our opcode 173. Let's turn that into hex so you can actually compare. You see it's 0x80, which is our opcode here. Now, after that should be, well, first of all, this 3 here indicates absolute for that instruction. So there's going to be 2 bytes after that. So let's increment this by 1, which brings us up to CE1F, and there is 80. And let's bring it up one more to CE20, and we have 0x1. And that is read in the opposite byte order because the 6502 it had the wrong endianness compared to today's computer, I say, because it's the low byte first and then the high byte. It doesn't really make sense if you think of it as binary numbers having the least significant bit on the right as we do with regular numbers. Our least significant digit is always on the right and our most significant digit is always on the left, so the 6502 is the opposite of that, and I don't remember what type of endianness that is, but it's the wrong one for me. However, here's the 2 addresses, 0x80 and 0x1. Those are combined, and we shall read this as a 16-bit integer, and it's combined as 0180. And if we read that, we get 0x0, which doesn't make sense at all for shit. Okay, you're using tilde. Try using quake. It's written in Python, totally worth it. What's tilde? Oh. Something tells me I shouldn't Google everything I see in chat. Could you explain a bit more, Pankai Duhare? Sorry for butchering your name. Anyway. Stupid screens. What I was gonna... Oh, my terminal and emulator. It's Terminator. It allows for quite cool splitting and stuff. And that's about it. That's why I use it. It's like, from what I remember, it's like the most searched. Well, it's the first terminal emulator that shows up when I googled about terminals that could literally just split. And I do think it has support for groups, so you can name your groups and then you can refer to other terminals from within that. And I apparently broke my fish prompt, but yeah. I think if we go to man terminator, there should be some information over here. Flexible arrangement of known terminals, blah blah blah. Yes, Tmux, I've used that in the past. The cool thing about Tmux is that you can literally just detach a whole set of you can literally detach your screen of split terminals, which I find very, very powerful, especially on servers that you are connected to via the internet and that you might lose connection to every once in a while, because your session is almost always preserved. You can almost always return to it, which I find saving of heart attacks, I should say. Anyway, yes, absolute reading. Let's get back to that. Over here, we do a bus read, so we get 16 bits of what's ahead of our program counter, which gets our, well, 2 bytes, 16 bits, and then that is used in the function to read again. So this location should theoretically contain 0x33. It does not. And last time I checked, that contains 0x0. Something's wrong here, but whatever. Yes, in fact, even the same machine, if you just log out and reset the session persist. Ah, that I didn't know. Thank you, sir. So that's the issue with the CPU right now. I have no idea if it's an actual addressing issue, or actually wait, let's just change this real quick. Optimization. Instead of moduling, just Bitwise ending it with 0xFF has the same effect. Still 863, so yeah. Anyway, that's what we're not here for. We're here for NES, PPU. Well, let's just start somewhere, I guess. At the top, registers. We have to define all these. Wait. Where's I need to see that memory map again. There's PPU registers. There's 8 of them. And then it's mirrored. Oh, I saw something I might wanna check. PPU memory map. Oh yeah. I forgot, I do have a mod player here. Let's play some mod music. Is that too loud? I don't know. My voice is at least loud as an audio by quite a bit, so I assume there is no problem there. I have to lower my volume locally. But yes. Also, instantly, that was a Windows program. Yes, I'm running Linux. In today's day and age, that's not magic. It wasn't when Wine came out. Shit. PPU has a totally separate address space. Sorry, I just died a little inside. Oh no, shot's active. What the hell? True. Yeah. Yeah, exactly. Wine used to be magic in 1999. Not so much anymore. The NES has 2 kilobytes of RAM dedicated to the PPU, but it can be expanded by the cartridge apparently. Oh yeah, the PPU has its OEM memory. Okay, so far it seems like the PPU is not really a CPU in of it itself, it just follows a strict set of things it does every frame so far. Which is... But it does seem to have some kind of special capability to accept and spit out data through some... I don't know. Okay, we're back here. Yeah, let's check the PPU power up state and see how convoluted it is. Often set. What the fuck does that mean? Okay. NT RAM. What the fuck does that mean? In control mode. Does that mean like the regular RAM for the PPU? Can I like position this? Oh yeah, yeah boy. There we go. I was messing away. What the fuck? Okay, now this just got weird on me. You have a hair. Apparently the piece of green code you see in front of you fails 50% of the time after reset, but only 11% of the time after it's been running. What? Modic. Is there an implementation of PPU in C or other language we can look at quickly? Yeah, I was actually about to do the same. Thanks for bringing it to my attention, Sugar. Let's see here. PPU, NES PPU implementation C, why not? When was this written? 2013, holy shit. PPU.C is master. I am happy now. Yes, I am actually happy now. Not as long as I thought it would be. This is actually... I do have problems understanding the arrow pointing thing with C, but other than that, I think this can be deciphered into Python quite easily. Just need to understand the underlying architecture of this thing. Void OIM run while one. Just do things, nothing. Just while one. Let's see here. Is there like a frame, like initial render that I can find that we can work from? Probably this one called PPU render, this one, render run maybe? Defines background palette, pixel and color. Loop unit is 1 clock. Okay. And then some things I don't understand. Background palette is a static number plus 3 times some pointer magic. I really need to understand pointers right now. Wait, see, hold on. This is what I need to understand. Yeah. Arrow operator, yes, help me. Arrow operator is used for accessing members of structure. Oh, so it's basically the dot in all the other languages. I probably just aggravated on other people, but that's not dwell on that. So we need to figure out what, oh, the PPU, pointer PPU. No, the question is this at latch in the PPU, or is it? No, it must be the at latch in the PPU. It's shifted down by the cycle modular 32 divided by 8 times 2. So that's how we find out which palette we're using. Make the pixel from the bit pattern. Get the color from the palette or the background color. And then draw it. Ah, this is not too bad actually. I could basically copy most of this over and just do some finer replacing and then some syntax editing and we're done. And that's what I will do for the map included here, because I'm not gonna rework this out, I'm just gonna copy that over. Stupid stuff like that. Why is this open? Go away. Alright. Let's get going, but something tells me I should read into the PPU to a new file. No. I'll shoot myself later. Once I realize what I've done, but I can just move it to another file then. Don't do the work if you don't have to. So, we need to define some stuff. Better start somewhere. That is an excellent idea. Not 100% sure to what I've mentioned within the last 10 seconds, but yes, we have to start somewhere. And I have to keep this bus architecture thing, so maybe no. The PPU is gonna have another bus map. I have no idea if you heard that, but it was like strange buzzing noise. There's it again, what the hell? There's something wrong with this mod file. Hey mod file, get out. Sure. Let's define the PPU's own memory map, I guess. I probably want to split up all of these things into actual separate things, because it will be easier to manage in code, and I don't have to as much data shifting and moving and crap on the fly. I can just have it almost already sorted in a nice and neat space and just... I don't know, it's like indexing a library a bit better. So we have a bus map on the PPU. Shoot me. Help me. I'm literally gonna take this, copy it over, and remove most of it. I just want the same kind of structure. What like? Something like that, and now we just need to re-add all of this shit in. So from 0 to 0FFF, we have pattern table 0. Oh yeah, that makes sense. I should have known that. Let's define our things that we're actually going to put in here. Self dot pat tab 0. It's a range of memory, so... Also, I'm getting tired to do this 0 for underscore in X range. So maybe I should have a helper function for that. Look at me just being lazy AF. Define empty array length return. Wait, how long was that? 8. Ooh. I'm at a point where the PPU needs the helper functions. And the helper functions file is originally solely dedicated to the processor class. What do I do now? I keep helpers separate and I just keep doing what I do. Boom. Something said. Of course. Kinda sucks, but it's working. This is the point where the project turns into a spaghetti mess. Both the processor, APU and PPU are both importing the helper locally. What I should do at this point is just remove it from each class as such and import it globally. But here comes the hard part. Changing all the selves to nothing. Damn it. Because now it won't run anymore. what the hell I'm doing, but sure. Yay! It has no instance of NTLA because it has to be like that and that. And now I have to change all of the helpers to not have the self thing. However, these functions should be located in the processor. Okay, they are there. All of them. Where the fuck is... Where is it? There. Long. Yeah. You fucking what? What's the content about? Oh. What's this one called? Human Revelation, okay. I think that's a fairly modern song. You can probably check. Details. (2016), 17th week of 2016 by Jackim. Restructuring the project should be today's title. All of these I can't do it because how is it gonna get its local processor instance for it? It's not gonna know what it's gonna do. It's not gonna know what to do with what instance. It doesn't have a reference. If I do it this way. Wow, lol. Unable to connect to chat. Yeah, stop, okay, what the f... This is not what I wanted, YouTube chat thing. Again, unable to connect to chat. Please try again. Yeah, shoot yourself. Okay. I can't do it. Her. Oh, there we go. Wow. We're back to working order. Oh, speaking of, I should probably enable the reset on this thing. And I shall run it. I shall run the NES test as it would run from a console normally, and it will just sit at a menu and wait for key presses, I think. Yes. So that's why I want to get the picture process unit working, because it's obvious it's pushing something to the PPU, and that now it's just waiting for controller input, because the arguments or the opcodes it's executing is 0x80, which I think is LDA, which loads into the accumulator, and then we have 0x10, which is actually branch if it's plus. Yes. So branch if not negative, essentially. But why does that pull for controller input, you may ask? Well, I say it's because that LDA is reading straight from the I/O. It's reading straight from the controller port, which is actually defined here. So theoretically, there we go. X amount of buttons are being held on the controller. If I run it now, it should... C00C and Z009 instead of... Oh, it's the same. Whatever, that's disappointing. I thought it would read directly from control inputs. Well, we can actually run Tetris and then it crashes promptly. But it did do some shit with the stacks there a lot, and then it did some bunch of crap with the X and Y registers and then it died. Because it hits an unknown opcode and just, I don't know. Most of the instructions do work to a degree. And I've only seen it step out of sync with the actual way it should step through the memory once. And that was when running the NES test without a reset, so just straight into the test and then letting it fall through. At the end it just, or I think it's at the end for me at least, I can't emulate any further. But I searched up what line it is and it's like line 880 something. And it's just, I don't know, hard to describe. Let's not completely kill ourselves over such things. The PPU should not have the helpers. It should define its own things. How long is the pattern table? Are we still streaming? Yes, we are. I should probably like pause that. Sucking my bandwidth. Stop it. It's not good. Yeah, here's that implementation. I'll be using this a lot. There's a clock, there's a render clock, background clock, and OAM clock. SEM? Wait. I need to find out what that SEM is. Okay, my guess is that it's probably defined in NES.h. Find 4 times. No. Here's an implementation of addressing. Let's see if I do my absolute addressing correctly. Oh, I was reading the wrong thing. Absolute full address to be operated on is given 2 bytes following instruction. Don't forget that the 6502 is the least significant byte first, as I told earlier. This was not what I was looking for. Hey, I can just search in project, can't I? This repository, SAM. Where are they defined? What is SAM wait and SAM post? Oh. Block a semaphore. Oh, it's from the semaphore.h. Ah, this thing is event driven, holy crap, I'm okay, I'll promptly go and find a gun and load it. Okay, let's not get too excited and load the gun too soon. Let's do some more research. PPU cycle increase. If the cycle is over 340 instead of 0, and increases scan line. If the scan line is over 261, set the scan line to 0 and set the even frame to not even frame. That sample has not ever been heard ever. If you can't decode sarcasm, that was it. Hopefully that helps in your mission to decode sarcasm better. So this is basically threaded to shit. This is probably where everything happened. We have our NES as a pointer, and we have our PPU as a pointer, which is derived from our NES, which is what the PPU is within our NES and is within P. And as we run this function, it waits for a general clock. And then it posts a ready clock, a background clock, and an OEM clock. And then it properly increments the cycle. This code is already defined. Here. It's the same. Clean up? Question mark? Yes. Why is there duplicate code here? Is it exactly the same? P402610. P402610. It's the same, it's the flippin' same. It's called PPU cycle increase, man. Oh, whatever. Maybe I can commit that. Nah. Hold on, I think my parents are calling me. Blah, blah, blah. Oh. Looks like a lot of debug prints in here, so this is not finished. When was this updated? 2014. It might be a dead in the water project. Especially since OEM run is just empty. Feels like my brain is imploding in a way, but it's weird panning. Maybe it's just my headphones. No, it's just a mod file. Here's someone trying out OAM and then just regretting it. Using multi-line comments on every line. Why? Mate. Damn it. And the scissor. Where's that thing? Where's that thing I need right now? Of which name I do not know. It's probably on the desk when I just... Probably just being blind. No, it's not here. Whatever. Can I just need that to stretch it so I can cut this annoying piece of skin off. There we go. Let's get back to this and define the rest of our pattern tables and name tables. And later, OAM, object attribute memory. Ooh, this song I do like. Actually, this deserves me not talking while it's playing almost. Started talking there, forgot. But yes, I was gonna say, the name tables are mirrored. Yes, all of them are mirrored once. And after that, it's just palette RAM and mirrors of that, and we're done. I'm surprised there's only 20 bytes of palette RAM. Let's define the OAM. Do I know my hex right? Yes. No, that was not what I wanted to do. I want to do. Mockbliet. I keep hitting Control D when I'm not in the Python prompt, which kills the terminal instead of the non-running Python. This is funky, by the way. Well, I will have to start working on this thing. However, more distractions need to come in the way first. Bum, bum, bum. Bum, 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 bum. Bum, bum, bum. Bum, bum, bum. Bum, bum, bum. Bum, 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 bum. I think this one is called like jazz question. Yeah, jazz question mark. It's like jazz with break. Sure. How do I like bring up an actual window? Oh, here. Oh, it looks like I need a screen! Darn it. I'm just gonna nick their code here so I can get... Do I need the name equals main thing here? Fuck it, I'll code with it. Let's get the resolution of the NES again. It's in here. I know I've done that like 4 times this session. I know, I'm sorry. I'm triggered myself, I can't help it. Shit! It died! No! Import. Ammo. Do I do the same here? Yeah. Yeah, I should really like rewrite this thing, because I'm already starting to see issues. Like I don't. Everything is seated in on the processor. Like there's no main board. Like this guy here. At least this guy has like a NES object. He contains his processor and PPU in. I'm containing the PPU and cartridge in the CPU. It's... it needs to change. It needs to change. Tell you what, I'll finish this emulator. We'll have it running. It will run at least the CPU code as intended. And then we will look at it and say, that's a fucking mess. Let's do it again now when we've seen the hells it can bring, and do it in a different way that will not bring such hells. So yeah, P is m.processor. What do I do here? Yeah. I'll do the same here for no reason, but... Wow. Print unnecessary info. Creating window. Well, true. Yeah, I should really have a like base NES object that contains the clock divider. That's the thing I just realized, but we will worry about that some other day, as it's not applicable when we're writing our first emulator. Apparently, that's a big fat lie, but I'm assuming it. I'm assuming this will go fine, which it won't. Learn from my mistakes. I haven't even ran into the mistakes yet, but I know I will run into them. I just have a feeling. Wow. Psycho blight. Something in my throat, still there. That's annoying as fuck, holy shit. Hmm. You're not shitting. A NES emulator written in Go. Definitely not. You have to think. Yeah, I should probably implement mappers soon, since all games don't run on just a single page, as it's called. Ow. Why is key codes to find in this video? In handle key. Seems a bit odd. Trying to understand two different projects at once probably isn't good for you, but I'm trying. We'll define a frame buffer in the PPU. FBFR. What should I give it? Haven't I heard this already? I think I've heard this too. I swear I've heard all of these now. Yeah.
Is ready to go on.
Damn it. This issue with the clock cycle thing and the 6502 not being one opcode per clock cycle, it's variable, and by such you don't know the timing between the opcodes, and by such it's... The thing is that the PPU and the CPU needs to be running at the same time in a reliable way. Because the CPU has the ability to write to the PPU mid-frame and change what gets put on screen. This will be a generic render function. Screen dot set at
Adjust the volume, and the show is ready to go on.
yeah, this mod music is very insane. We've already heard all of these. Fuck that. No more music for today. I am sorry. Okay, so set at X is our key modulo with what was that hard coded with 340. I was about to say massive processor usage, mate. Do you reset? No, let's reset. Hi, game something. If we do pygame time clock take 60 FPS. Why did I get a topple back 6 and 0 from init? So we have a window that's theoretically rendered to. I will, in the ammo, import random in the PPU. Let's see, Python random. Oh, random. Psychobliet. I will kill someone if I do that once more. Is there rand int? Yeah, there is. Huh. Random or rand int. Shit. I will literally kill myself. Oh, it's in the map. Oh, it's not needed here. It's needed here. What? What do you mean got float? P dot P. Hold on, let's run this interactive. P dot PPU. This is only integers in the frame buffers. Where does it get the float? Oh, it's, wait. Are you serious? Someone's dying tonight. That's for sure. Really? Hmm. Drawing references to palette RAM, huh? Right here. How the fuck does the palette work? Question, how do you actually render this to the screen? Because all of this colors is just internal indexing for the PPU. NES test.log is using the same NES test log that I'm using. Here's our main executable, I think. It does have a main instruction. Graphics.h. Thanks for the color palettes. Don't mind me stealing that. Mm-hmm. I'm actually kind of amazed that I got a gray screen. That means that's the color 7C, 7C, 7C probably. Okay. I'm gonna sneeze. I chew for me. I'm gonna set up this bus map and then I'll be out of here. I think that's fine. Ah, the memory is just the name tables, so I don't need that. Let's just set up this so it works. So from 0 to 0FFF, we have pattern table 0. And after that, we have pattern table 1. I'll just have one name table for now. Hashtag what the fuck am I doing? Question mark. There's the boss map. As you can see, my eyes are getting slower and slower, which means that I should probably like stop this soon. So we are from 200 to 2 FF. Actually, there's mirroring going on here. There's a small typo here, and that should be an F. And other than that, I think I understand this. Oh, what the hell? I've been doing this wrong. That's all the bus mapping we need to do for the PPU. Oh, by the way, this chat is pretty much dead, yeah. Oh, and it reconnects as I like press it. Yeah, I agree, Pankaj. Sorry for butchering your name, but this chat actually sucks. Does it help by reconnecting? I guess not. Anyway. We have a gray window, which it's something. Solid color for a NES is bad though, because that means the CPU isn't communicating with it properly. And guess what? We are not doing communicating with it properly. Who would have thought? Hold on. If I run this and then like kill it and then check the PPU, what do we have in here? All of its registers are empty. I am now disappointed. I have some reading to do. Okay, so there's some under and overlapping I need to replicate. But yeah, I think I'm gonna stop here today. We nicked a palette from a C project. We nicked some other code to generate pixels from the same C project. We finds the 2 kilobytes of RAM, potentially up to more. Yeah, I think we will handle more of this next time. Maybe I'll print some of this specification out and this is the wrong thing. Huh. Oh. Yeah, I have things to read, things to debate whether to shoot myself over, and then what I really need to debate is whether I need to re-implement the clock cycles back into this thing so I can actually do accurate timing. Yeah. Not much more to see here. Yeah. Just like not really much more I can think of doing right now, because I need to tackle like 2 or 3 different dilemmas at once, one of which is frame timing, the other one of which is CPU timing, and the third of which is that the CPU has the ability to interact with the PPU mid-frame. All of which sort of go back to the fact that the 6502 is supposed to take multiple clocks to execute a single opcode. The thing is that it's not static as well. It's depending on if the page boundary is crossed on certain functions, it adds 1 clock cycle. So I need a way to implement that. Yeah, I'll think about it. I'll put my burnt out brain cells on it and see what kind of a bad idea I'll have next week, or tomorrow, or soon. Goodbye, and I will see you next time.